Chapter 13 Statistics. First exercise. Question number 1. A survey was conducted by a group of students as part of their environment awareness program, in which they collected the following data regarding the number of plants in 20 houses in a locality. Find the mean number of plants per house and which method did you use for finding the mean and why. We can do here this one in direct method because the values numbers are small, so directly we can do that direct method. First we have to write the table, given table, number of plants that we can take as class interval, then number of houses, that is frequency. Then the given frequencies, when we are adding, we will get that as 20. Sum of total number of houses, that is sigma fi is equal to 20. Now next column, midpoint of xi, class interval, midpoint of that class interval. To find the midpoint of the class interval, first you have to add the upper limit and lower limit and divide by 2. Lower limit is the first number, upper limit is the second number. When we are adding 0 plus 2, 2, that divided by 2, or take the average of lower limit and upper limit. So here we will get that as 1. Same way here, 2 plus 4, 6, 6 by 2, that is 3. 4 plus 6, 10, 10 by 2, that is 5. 6 plus 8, 14, 14 by 2, 7. Then after that we can write the rest in the order. Next is fi hi. This is the second column is fi, third is hi. So multiply that. 1 into 1, 1, 2 into 3, 6, 1 into 5, 5 into 7, 6 into 9, 2 into 11, 3 into 13, 39. Now we have to find the sum of the fi hi, sigma fi hi, which is equal to, here we are getting 162. Now to find the mean, we know the formula that mean is equal to sigma fi hi divided by sigma fi, which is equal to, here sigma fi hi we got that as 162. 162 divided by sigma fi, that is 20, which is equal to 8.1. So we can write the mean number of plants per house. Therefore, the mean number of plants per house is 8.1. That's the question. Find the mean number of plants per house. And the second part, which method did you use for finding the mean? That we can write direct method. So we can write we used direct method because numerical values of hi and fi are small numbers, so we can directly multiply and we'll get the answer easily. So we use the direct method. Second question, consider the following distribution of daily wages of 50 workers. Daily wages that we are in rupees that we can take as class interval, and number of workers, that is frequency. Then next is midpoint. Midpoint means lower limit plus upper limit divided by 2. So 500 plus 520 by 2, or from here we can take directly 510 between 500 and 520. So 510 here between these two, that is 530, 550, 570, 590. Next is DI. DI is equal to HI minus A. To make the calculation easier, we can take this as A. So in place of A, we can write 550. So now here we are minusing, subtracting here also. Let's say 550. And HI minus 550. 510, this is HI minus 550. So here we are getting the difference is 40 and this is the smaller number, so minus 40. Minus 20, 550 minus 550, that is 0. This is HI, so 570 minus 550. 20. 590 minus 550, that is 40. Now next HI minus A by H. Here H is equal to, we have taken A is equal to 550 and H is equal to 20. In place of H we can divide by 20. So HI minus A already we got that number divided by 20. Here we will get minus 2, minus 1, 0, 1, 2. Now we are going to multiply Fi Ui. 12 into minus 2, minus 24, minus 14, 0, 6, 20. Then we have to calculate the negative numbers, integers together. 38 here, minus 38, here it's coming 26. Then the difference between minus 38 and 26, that is sigma Fi Ui. So minus 12, minus 38 and 26, the difference between that 12 and the bigger number is negative, so minus 12. Then we can apply there in the formula. This is the step deviation method. Here mean X bar is equal to A plus sigma Fi Ui by sigma Fi into H. Here we can replace the values. A as 550 plus sigma Fi Ui, that is minus 12 by sigma Fi is 50, that into H, which is 20, which is equal to 550 plus minus 24 by 5, which is equal to 550 minus 4.8, 545.20. So we can write the mean daily wage of the workers is equal to rupees 545.20. Question number 3. The following distribution shows the daily pocket allowance of children of a locality. The mean pocket allowance is given, that is rupees 18. So we can write mean, which means X bar, that is given as rupees 18. Find the missing frequency F. For that, first daily pocket allowance in rupees, that is class interval, Fi number of children, that is frequency. When we adding all these frequency here, we are getting sigma Fi is equal to 44 plus F. Here missing frequency F. So remaining numbers just add, we will get that as 44 and that plus F. Then Hi, the midpoint. That is here 12, 14, 16, 18, 20, 22 and 24. Next is coming Fi, Xi. But we have to multiply Fi and Xi. 7 into 12, 84. 6 into 14, 84. 9 into 16, 144. 13 into 18, 234. Then 20 into F, that we can write as 20F. F is same as that. Then next number 5 into 22, that is 110. 4 into 24, 96. Then when we are adding this all, sigma Fi Xi is equal to all the numbers. When we are adding, we are getting 752. That plus this 20F is there. So we know that the formula mean x bar is equal to sigma Fi Xi by sigma Fi. That means x bar is here given as 18. We can write that is 18 is equal to sigma Fi Xi, that is 752 plus 20F divided by sigma Fi is 44 plus F. Cross multiply. 18 into denominator 44 plus F is equal to the other side 752 plus 20F, which implies when we are opening the bracket 18 into 44, that will come 792. 792 plus 18 into F. 18F is equal to 752 plus 20F. Move this 752 to the left side. 792 minus 752 is equal to already here 20F, that minus this 18F. Here we will get that as 792 minus 752, that means 40. 40 is equal to 2F, which implies F is equal to 40 by 2, that is 20. So we can write the missing frequency F is equal to 20. Question number 4. 30 women were examined. That means number of women is 30, sigma Fi. Just add all the frequencies, we will get that as 30. Examined in a hospital by a doctor, and the number of heartbeats per minute were recorded and summarized as follows. Find the mean heartbeat per minute for this woman, choosing a suitable method. So step deviation we can use, that easy for calculation work. First we have to calculate midpoint. For that 65 plus 68 divided by 2. So when we are adding 65 plus 68 and that divided by 2, we will get that as 66.5. Same way, 68 plus 71 divided by 2. 71 plus 74 divided by 2. It's equal to 72.5. After 2, 3, then we can same way. 3 is adding 6 plus 3, 9, 9 plus 3, 12. Then it will come 75.5, 78.5, 81.5, 84.5. Now one of this number we can take as A, the middle one. Here 3, here also 3. So we can take this as A. Then DI, next column, HI minus A. A is here 75.5. That we can write, we want here also 75.5. A is equal to, now HI minus, that is 66.5 minus 75.5. We are getting 9 minus 9. Here 69.5 minus 75.5. Small number minus bigger number. Minus 6. Minus 3. 7.5 from that. 0. Here 3. 6. 9. Here we can take H as the common number. That 3. So H is equal to 3. Divide by 3. When we are dividing minus 9 by 3, we will get minus 3, minus 2, minus 1, 0, 1, 2, 3. Then this is the UI, FI. Multiply that. Minus 6, minus 8, minus 3, 0, 1 into 7, 7, 8, 3 into 2, 6. Then add all the negative numbers first. Minus 17. Then the difference between these two. So 21 plus minus 17, that is sigma FI UI or UI FI is equal to 4. Now we can apply these values in the formula. So mean is H bar is equal to A plus H into sigma FI UI by sigma FI, which is equal to A is 75.5 plus H is 3, that into sigma FI UI, that is 4, sigma FI is 30. We can divide by 3, here 10, which is equal to 75.5 plus 4 by 10. 4 by 10 is 0.4. It's equal to 75.9. So we can write, therefore the mean heartbeat per minute is equal to 75.9. Question number 5. In a retail market, fruit vendors were selling mangoes kept in packing boxes. These boxes contain varying number of mangoes. The following was the distribution mangoes according to the number of boxes. Here we can see 50 to 52, then 53 is coming. So the class interval is not continuous. Here the gap in between 52 and 53. Which means 15.5 or 15.6 is where in which interval is coming. It's not mentioned. So we have to make it continuous. To the given, the difference is 1. 53 minus 52, that is 1. Take the half of the difference. So the given data is not continuous. We have to add 0.5 to the upper limit and then subtract 0.5 from the lower limit to make it continuous. For that, first we have to check the given data is continuous or not. If it is not continuous, find the difference between these two. Lower limit of the second class and upper limit of the first class. That is 1. Take the half of that and that we have to add to the upper limit and subtract from the lower limit. So 50 minus 0.5, it will come 49.5. 53 minus 0.5, 52.5. Upper limit we have to add. So 52.5, 55.5, etc. Now we can see that is continuous. 14.9 to 52.5. Then starting from 52.5 to 55 point, like that way. So first we have to make the class interval as continuous. Then total number of boxes, sigma fi, that we got that as 400. Now to calculate a midpoint, add the lower limit and upper limit, divide by 2. We will get here that as 51. 50 to here also add both the numbers and divide by 2. Now we can see the difference, 3. Now from here, one of the number we can take that as A, 57. A is equal to, A means assumed mean. Which is equal to here 57. Now 51 minus 57, we will get that as minus 6. 54 minus 57, minus 3, 0, 3, 6. Then h we can take here all these numbers divisible by 3. So h is equal to 3. When we are dividing by 3, here minus 2, minus 1, 0, 1, 2. Then FIUI. This is UI. Here this is FI. When we are multiplying, minus 30, minus 110, then 0, 115, 2 into 25, 50. Then add the negative numbers and positive numbers, find the difference. Sigma FIUA. So when we are adding the negative numbers, here minus 30 plus minus 110, that is minus 140. Here 165, difference of these two, that is 25. The bigger number is positive. A means the assumed mean, H means the class size. That is coming here also, reflecting here also. So when there in the formula, H bar mean is equal to A plus H into sigma Fi ui by sigma Fi, which is equal to A is 57 plus H is 3 into sigma Fi ui, that is 25, sigma Fi is 400. When we are simplifying, 57 plus 3 into 25, 75. This we can simplify. When we are simplifying, 0.1875, which is equal to 57.1. We can round it, 19. Therefore, the mean number of mangoes kept in a packing box is 57.19. And which method you choose, that was there in the question. So we chose step deviation method because calculation was easier here. Sixth question, the table below shows the daily expenditure on food of 25 households in a locality. So daily expenditure we can take as class interval. It's continuous class interval 100 to 150. So we can write the same. Then number of households, that is frequency. Next column, midpoint. Midpoint, lower limit plus upper limit divided by 2. Here we know that clearly 125 is the midpoint. 125, here 175. It's the midpoint. Now we can choose one as the middle one as A. So here Xi minus 225. Assumed mean A is equal to 225. Now 125 minus 225, that is coming here minus 100. 175 minus 225, that is minus 50. Here 0. 50. 325 minus 225, 100. Now H, class size. Here we can see the class size, multiple of 50 is coming. Or here also the same, class size is 50. So H is equal to 50. When we are dividing each number with 50, here minus 2, minus 1, 0, 1, 2. Then Fi, Ui, this Ui, Fi. Minus 8, minus 5, 0, 2, 4. When we are adding the positive numbers here, 6, negative numbers minus 30. So sigma Fi Ui is equal to minus 7. And we can write the formula and apply the values in that. Now mean is equal to A plus H into sigma Fi Ui by sigma Fi, which is equal to A is here 225 plus H is 50, that into sigma Fi Ui, that is minus 7 divided by sigma Fi 25. Here we can divide by 25 2 times, which is equal to 225 plus 2 into minus 7, that is minus 14. So 225 minus 14 is equal to 211. So we can write here the mean daily expenditure is equal to rupees 211. Question number 7. To find out the concentration of SO2 sulfuric acid in the air per million. The data was collected for 30 locations in certain city and presented below. Find the mean concentration of sulfur oxide in the air, SO2. So class interval is continuous. We can take it the same frequency, then midpoint. Here add the lower limit and upper limit, divide by 2. Take the average of this. We will get here that is 0.02. Here 0.04 plus 0.08 divided by 2, 0.06. Similarly, we will get 0.10, 0.14, 0.18, 0.22. Then FIHI, these two. 4 into 0.02, 0.08, 9 into 0.06, 0.54, 9 into 0.90, 2 into 0.14, 0.28, and here 0.72, here 0.44. Here direct method, so we can apply the formula sigma Fi Hi divided by sigma Fi. Here we got sigma Fi, sum of all the frequency, that is 30, and Fi Hi as 2.96. So mean is equal to H bar is equal to sigma Fi Hi by sigma Fi, which is equal to 2.96 divided by 30. Is equal to 0.099 ppm. ppm means in parts per million. So the means concentration of SO2 in the air is equal to 0.099. Question number 8. A class teacher has following absentees record of 40 students of a class for the whole term. Find the mean number of days of a student was absent. So class interval, we can take the same order, and number of students, that is frequency. Total 40 students are there in the class. When we adding this all, we will get that as 40. Now midpoint. Add the lower and upper limit, divide by 2. 0 plus 6, 6 by 2, that is 3. Here 6 plus 10, 16 by 2, 8. Then FIHI, multiply 11 into 3, 33, 80, and find the sum of FIHI. Here sum of FIHI we are getting 499, and sum of the frequency, that is 40. So we can put here 499 divided by 40, which is equal to 12.48. So we can write, therefore the mean number of days a student was absent is equal to 12.48. Mean number of days a student was absent, 12.48. Question number 9. The following table gives the literacy rate in percentage of 35 cities. Find the mean literacy rate. So first one we can take as the class interval, then frequency. Total frequency as 35 we are getting. Now HI, lower limit plus upper limit, divide by 2. Here clearly we know that 50 is the midpoint. Here 60, 70, 80, 90. Here we can see the midpoints are big number. So we have to go for the step deviation method. That is easy for the calculation work. We can take one of the number that is the assumed mean, the middle one. So HI minus 70. So 70 minus 50 minus 20 minus 10, 0, 10, 20. Then same way H we can take here multiple of 10, or the class size, that is 10. So when we are dividing by 10, minus 2, minus 1, 0, 1, 2. Then multiply sigma Fi ui, minus 2 into 3, minus 6, minus 10, 0, 8, 6. Minus 6 and plus 6 will cancel. So here 8 and here minus 10. Sigma Fi ui is equal to minus 2. Here the assumed mean, that is 70, class size, that is 10, and the formula mean is equal to h bar plus a plus h into sigma Fi ui by sigma Fi. If the values are bigger, then just go for the step deviation method, that is easy. In place of direct method, more calculations it will come there in the direct method. So when we are applying this step deviation, calculation is easy. Here A is 70, H is 10, sigma Fi ui, that is minus 2, sigma Fi is 35, by 5 here 2, 7, is equal to 70 plus minus 4 by 7, which is equal to 70 minus 0.57. Is equal to 69.43. So So we can write the mean literacy rate is equal to 69.43%. Question was what percentage? Find the mean literacy rate. It's given in percentage. So 69.43%. Second exercise. First question. The following table shows the ages of the patients admitted in a hospital during a year. That we can take as class interval. And number of patients, that is frequency. Find the mode and mean of the given data. Compare and interpret the two measures of central tendency. First we can calculate mode, class interval and frequency. So to find mode, first we have to check the highest frequency. We can see 23 is the highest frequency here. Then round that with the class interval, that frequency with the class interval. Now we can see the model class is, the highest frequency is 23 and corresponding class interval, that is the model class. And here this is the lower limit L, we can take that as, this as F1, F0, then F2. Then the difference between or the class size, that is H. We know the formula mod is equal to L plus F1 minus F0 by 2 F1 minus F0 minus F2 into H. We can put the values here. L is the lower limit of the model class 35 plus F1, the frequency of that model class, that is 23 minus F0, just above the frequency, 21 by 2 into F1, that is 23 minus F0 21, again minus F2, that is 14. That into H, H is the class size, 45 minus 35, that is 10. When we are simplifying that, 35 plus here 23 minus 21, that is 2. Here 2 into 23, 46. 46 minus 21 minus 14. That into 10. It is equal to 35 plus 2 by 11. So you have to minus from 46, so you will get 11, that into 10, which is equal to 35 plus 1.8. That means mod is equal to 36.8 years. Now we got mod. Next we have to calculate mean. For that we can use the same table. First we have to find the midpoint of HI. 5 plus 15, 20. 20 divided by 2, that is 10. So we can write the midpoint of each class interval. 10, 20, 30, 40, 50 and 60. It's big numbers, so we can use the step deviation method. The middle one we can 30 and 40 there, any one of that we can take that as A, and HI minus 40 we can take. So HI minus 40. So we will get here 40 minus 10, that is 30, minus 30, 40 minus 20, minus 20, not 40 minus, HI minus 10 minus 40, difference, and put the negative sign. 30 minus 40 minus 10, here 0, then 50 minus 40, 10, 60 minus 40, 20. Now here H is equal to 10. We can take H as 10. So all multiples of 10. So when we are dividing by 10, H is equal to 10. Dividing by 10, it will come minus 3, minus 2, minus 1, 0, 1, 2. Then we have to multiply. ui fi minus 3 into 6 minus 18 minus 2 into 11 minus 22 minus 1 into 21 minus 21 here 0 1 into 14 14 2 into 5 10. Then first we have to calculate the positive number, add the positive numbers, negative numbers, and then find the sum. Sigma ui fi is equal to, here total frequency that is 80, and when we are adding sigma UIFI that is minus 37. Here A is equal to 40 and H is equal to 10. Then the formula, mean is equal to A plus sigma Fi Ui by sigma Fi into H, which is equal to A is 40 plus sigma UIFI that is minus 37, sigma Fi 80 into 10, which is equal to 40. We can cancel with zeros with the 10, minus 37 by 8 is equal to minus sign, plus of minus, that is minus sign, 4.63, which is equal to 35.37 years. Here the question was find the mode and mean. We got the mode as 36.8 years and mean as 35.37. And then compare and interpret the two measures of central tendency. So we can write maximum number of patients admitted at the age of 36.8 years. That means mode, maximum number of patients admitted at this age, 36.8. And average age, average means mean, average age of the patient is 35.37 years. Second question, the following data gives the information of the observed lifetimes in hours of 225 electrical components. Lifetime in hours 0, 20, 20, 40, etc. that we can take as the class interval, and frequency also it's given. So from here we can see the highest frequency is 61. So the model class is corresponding in class interval. Is the model class 60. You can write maximum frequency F1 that is 61, model class is 60, 80, the same class interval. And then here this is F1, top F0, this F2. This is the lower limit L. So we can write mod is equal to L plus F1 minus F0 by 2F1 minus F0 minus F2 into H. Here H is the class interval. So when we are putting the values here, L is 60 plus F1 minus F0, 61 minus 52 divided by 2 into F1, 122 minus F0, 52 minus 38. That into 80 minus 60, 20. So when we are doing that, 60 plus 9 by 32 into 20. We can simplify, divide by 4, 5. That means 60 plus 45 by 8 is equal to 60 plus 5.625, which is equal to 65.625 hours. So we got mod is equal to 65.625 hours. So we can write, therefore the model lifetime of the components is equal to 65.625 hours. Third question, the following data gives the distribution of total monthly household expenditure of 200 families of a village. Find the model monthly expenditure of the families. Also find the mean monthly expenditure. So first we can calculate the mod. Frequency, we can see 40 is the highest frequency, that we can take as F1. And the model class is 1500 to 2000. So this is the L. L is equal to 1500. Here F0, F2. And here the H is 500, the difference between upper limit and lower limit, class size. Now maximum frequency F1, that is 40. So model class is 1500 to 2000. Mod is equal to formula we write, and then we can put the values here. Is equal to L, that is 1500, plus F1 is 40 minus 24 divided by 2F1, that is 80. 2 into 40, 80, minus F0, 24, minus F2, 33. That into H. H means class size. 2000 minus 1500, that is 500. Which is equal to 1500 plus 40 minus 24, that is 16, by 80 minus 24, 47, so 16 by 23 into 500, which is equal to 1500 plus 347.826 is equal to 1847.83 826, that we can round as 83. So that is the mod. Next we have to find the mean. For that, first we have to calculate the midpoint HI. Add the lower limit and upper limit and divide by 2. So 1250. Here the midpoint is 1750, 2250, 2750, 3250, 3750, 4250, 4750. Now we got midpoint HI. Next we can take big numbers, so we have to follow the step deviation method. That is easy for calculation work. So we can take A as the mid one of that value, 2750 as A, which means HI minus 2750. So HI minus 2750, here minus 500, here 0, so H we can take as 500 divided by 500, then we will get that as minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. Then FI UI. This is FI UI. So that will come as minus 3 into 24, minus 2 into 40. You can write it here. Here A is equal to 2750 and H is equal to 500. Total frequency 200. Sigma FI UI is minus 35. So we can apply the values here. A is 2750 plus sigma fi ui, that is minus 35, divided by sigma fi 200 into h is 500. So which is equal to 2750 minus, when we are simplifying this, 87.5, which is equal to 2662.5. That is model monthly expenditure is equal to 1847.83. And mean monthly expenditure is 2662.5 rupees. Question number 4. The following distribution gives the state-wise teacher-student ratio in higher secondary schools of India. Find the mode and mean of this data. Interpret the two measures. Here, number of students per teacher, that we can take as the class interval, and number of states, that is frequency. Here the maximum frequency is coming 10. So the model class is 30 to 35. This is F1, F0, F2. L is 30. So we can write the formula mod is equal to L plus F1 minus F0 by 2 F1 minus F0 minus F2 into H. Then we are putting the values there for L is equal to 30 plus F1 10 minus 9 divided by 2 into 10 20 minus 9 minus 3. That into 5, which is equal to, so 10 minus 9, that is 1 by 8 into 5 by 8, which is equal to 30 plus 5 by 8 is 0.62, which is equal to 30.62. That's the mod. Now we have to calculate mean. For that, HI midpoint 15 plus 20 divide by 2. Here sigma fi ui is equal to minus 23 and sigma fi is equal to 35. So we can write A as 32.5. 32.5 plus minus 23 by 35 into 5. And we are simplifying. Is equal to 32.5 plus minus 23 by 7 is equal to 32.5 minus 3.28, which is equal to 29.22. So we can write most states we have a student teacher ratio is 30.6 and the on an average mean, that means 29.2. Question number 5. The given distribution shows the number of runs by some top batsmen of the world in one-day international cricket matches. Find the mode of the data. Here maximum frequency is 18. So the model class is 4000 to 5000. This we can mark as F1, F0, F2. L is here. Therefore, mod is equal to L plus 4000. 4000 plus F1 minus F0, 18 minus 4. 2 into 18, 36 minus 4 minus 9, that into difference, that is 1000 class size. So when we are calculating that, which is equal to 4000 plus 18 minus 4, that is 14 by 23 into 1000, which is equal to 4000 plus 608.7, which is equal to 4608.7. That is, the mode of the given data is 4608.7 runs. Question number 6. A student noted the number of cars passing through a spot on a road for 100 periods each of 3 minutes and summarized it in the table given below. Find the mode of the data. So number of cars that we can take as class interval, frequency also here given. Here we can see the highest frequency is 20, that we can take as F1, and the model class is 40-50, L is 40, F0 12, F2 11. So we can put the values in the formula. Mode is equal to L is 40 plus F1 20 minus 12 divided by 2 F1, that is 40, minus 12 minus 11 into 10, which is equal to 40 plus 20 minus 12, that is 8 by 17 into 10, which is equal to 40 plus 4.7 is equal to 44.7. So we can write the mode of the given data is equal to 44.7 cars. Third exercise, question number 1. The following frequency distribution gives the monthly consumption of electricity of 68 consumers of a locality. Find the median, mean and mode of the data and compare them. So we are trying to do all this in the same table. First, by using these two columns, we can find the mode, then cumulative frequency. From that we will get median, and HI step deviation method, mean, we can find the remaining columns. So first we are going to find the mode. Model class, the highest frequency is here 20. So we can take this as the model class. This is F1, F0, F2, and this is L. So mode is equal to here L plus L is 125, that plus F1 is 20, 20 minus 13 by 2 F1 is 40 minus 13 minus 40, that into H, that is 20, which is equal to 125 plus 20 minus 13 divided by, that is here 7 by 13 into 20, which is equal to 125 plus 10.76. That means mode is equal to 135.76 units. Next we are going to find the median. For that, cumulative frequency we need. First frequency, that is 4, then we have to add 4 plus 5, 9, then 9 plus 13, like that way cumulative frequency get right first. Here cumulative frequency and the total frequency also is equal to 68. Then we can see here n is equal to 68. So n by 2 is equal to 34. 68 by 2, that is 34. We can see the cumulative frequency here. This, the median class is 125, 145 and 22 is the cumulative frequency. So median class is equal to 125, 130, 45. Now here L is equal to 125 and Fy is equal to 20, cumulative frequency is equal to 22. So we can write median is equal to L, that is 125, n by 2 is 34, minus Cf, that is 22, by F, that is 20, into class size 20. So this 20 and 20 will cancel, which is equal to 125 plus 12. That means 137. 137 units. So we can write, therefore median is equal to 137 units. Now we got mode and median. Rest of the columns for mean. We can draw different columns or tables for mode, median and mean. But here everything together in one table. This way also we can do it. Now for the mean. First we have to write the HI. That means midpoint. 65 plus 85 divided by 2. Here we can take 135 the middle value, that is A assumed mean, and HI minus 135. 75 minus 135, that is minus 60. 95 minus 135 minus 40 minus 20 0 20 40 60. Then HI minus A by H. H we can take as 20. A is 135 and H is equal to 20. When we are dividing by 20, here minus 3, minus 2, minus 1, 0, 1, 2, 3. Then Fi Ui. This is the frequency Fi into Ui. Minus 3 into 4, minus 12, minus 2 into 9, minus 18, minus 1 into 13. Sorry, here this one for minus 12, minus 2 into 5, not 9, minus 2 into 5, 10 here. When we are making the columns, more columns, be careful when writing. Then minus 1 into 13, minus 13, then 0, 1 into 14, 2 into 8, 3 into 4. Now here A plus mean is equal to A plus sigma Fi Ui by sigma Fi into H, which is equal to, in place of A, 135 plus Fi Ui we got from here, that is 7. Sigma Fi is 68. H is 20, which is equal to 135 plus 2.05, which is equal to 137.05 units. So we got mode as 135.76 units, median as 137 units, and mean as 137.05. Here the comparison, the three measures are approximately the same in this case. So everything in one table we calculated. When we are drawing the table or writing that, be careful when we are doing in the same table. Otherwise, for each calculation work, we have to draw separate tables. Second question, if the median of the distribution given below is 28.5, find the values of x and y. Here we can see two frequencies are missing that we have to find. And here, what is given? Total frequency is given as 60 and median is given as 28.5. So from that we can add the frequencies first. When we are adding, we are getting 45 plus x plus y. At the same time, that is given as 60. So we can write 45 plus x plus y. When we are adding the frequencies, we are getting this, which is equal to total frequency is given as 60, which implies move 45 to the other side. X plus y is equal to 60 minus 45, which is equal to 15. This is equation number 1. Now here median is equal to 28.5, that also given. If the median is given, then we can take that as the median class. Here this is the median class. Also we have to find the cumulative frequency. When we are finding the cumulative frequency, first one, that is same 5, then is 5 plus x, then plus 20, 25 plus x, then 15, 40 plus x, then 40 plus x plus y, then 5, 45 plus x plus y, the same as that total here. And when we are taking the median class, just circle it, and this is the cumulative frequency. Here total frequency is 60, that means n is equal to 60, which implies n by 2 is equal to 30, and L is equal to 20, F is equal to that also 20. Then we can put that in the formula, which is L is equal to 20, then n by 2, that is 30, minus CF, that is 5 plus x. So minus sign is here, keep in bracket that one, 5 plus x, divided by frequency, that is 20, into h is 10 class size, which is equal to 20 plus 30 minus 5 minus x by 2. Again that is equal to 20 plus 30 minus 5, 25. 25 minus x by 2. Now here we have median is given as 28.5. So we can put that 28.5 in place of median. 28.5 is equal to, here we got 20 plus 25 minus x by 2. When we are moving this 20 to the other side, we will get here. So which implies when we are moving 20 to the other side, 8.5. 8.5 is equal to 25 minus x by 2. Cross multiply, which one? 17 is equal to 25 minus x, which implies x to the other side, and 25 minus 17, 8. So x is equal to 8. Now put that value in equation number 1. So 1 gives x plus y is equal to 15. In place of x we can put 8. 8 plus y is equal to 15, which implies y is equal to 15 minus 8 is equal to 7. Now we can write, therefore values of x is equal to 8 and y is equal to 7. Third question, a life insurance agent found the following data for distribution of ages of 100 policy holders. Calculate the median age if policies are given only to persons having age 18 years onwards but less than 60 years. So here it is given below 20, below 25, etc. We can take that as from 15 to 20 class interval, 20 to 25, 25 to 30, etc. And the cumulative frequency is less than cumulative frequency is given in the question. So first we have to find the frequency. That means in between the class interval. Frequency we have to find. For that, first number we can write the same. Then 6 minus 2, 4. 24 minus 6, 18. 45 minus 24, 21. So the number which one just subtract and get the frequency of each class. Here total frequency, that is 100. So n by 2 is equal to 50. And 50 is coming here, the cumulative frequency 45 is here. So the next one after 50, that class will be the median class. So we can take this as the median class. Here 45, but we got n by 2 is equal to 50, 50 or above 50. In the cumulative frequency, that we have to take the median class. So here median class is 35 to 40 and frequency is 33. Cumulative frequency means just before. This is cumulative frequency. This is L. Now we can put the values here in the formula. L plus n by 2 minus F by F into H, which is equal to, in place of L, 35 plus n by 2, that is 50, minus 45 by 33 into class size 5, which is equal to 35 plus 50 minus 5, 5 into 5, 25 by 33, which is equal to 35 plus 25 by 3, 25 by 33, we will get that as 0.76, which is equal to 35.76. Therefore, we can write the median age is equal to 35.76 years. Question number 4. The lengths of 40 leaves of a plant are measured correct to the nearest millimeter and the data obtained is represented in the following table. Find the median length of the leaves. Here we can see the class interval is not continuous, 118 to 126, then starting with a 127. So we have to make the class interval continuous. For that, see the difference, 127 minus 126, that is 1. Half of 1, that is 0.5. So 0.5 we have to add to the upper limit and subtract from the lower limit. So when we are subtracting 0.5 from 118, we will get 117.5. Add 0.5 to the upper limit. So 126.5. Here 135.5, 144.5, etc. Same way, subtract from the lower limit. 127 minus 0.5, that is 126.5, 135.5, etc. Now here we can see it is continuous. 126.5 and starting from here also again 126.5. So class interval, first we have to make it continuous. Then frequency is given. We can find the cumulative frequency. 3, 8, etc. Now here cumulative frequency we got 40. We can check with this one. Some of the frequencies that are also 40. That means here n is equal to 40. So n by 2, that is 20. In cumulative frequency column, 20 or above that. So that means next frequency is coming 29. So that will be the median class. This is the median class. This frequency, lower limit and cumulative frequency. So median is equal to L plus N by 2 minus CF by F into H. We can put the values here. L as 144.5. N by 2 20. Cumulative frequency is 17. Frequency is 12. H is 9 here. The difference between the upper limit and lower limit. Which is equal to 144.5 into 20 minus 17, 3 by 12 into 9. Which is equal to 144.5 plus 9 by 4. So here 144.5, 9 by 4, that is 2.25. So it's equal to 146.275. 2.25 plus 0.5, so 146.75. When we are adding 0.5 and 0.25, it will come 0.75. Therefore, the median length of the leaves. Question was to find the median length of the leaves, which is equal to 146.75 mm. Fifth question. The following table gives the distribution of the lifetime of 400 neon lamps. Lifetime that we can in hours that we can take as the class interval. It's continuous class interval, and frequency also given, number of lamps, that is. First we had to calculate the cumulative frequency. So first number same 14, then 14 plus 56, it will come 70. Here total that n is equal to 400, same cumulative frequency also. Last one we are getting the same as 400, same as the total. Now total n is equal to 400, n by 2 200, then that 200 or above that number. That means 216 in the cumulative frequency. We got to take that as the median class. This is F, cumulative frequency, and L. So we can put the values here. L is equal to 3000 plus n by 2, that is 200. Cumulative frequency is 130. F is 86. H is 500. Which is equal to 3000 plus 70 into 500 by 86. Which is equal to 3000 plus 406.98, which is equal to 3406.98. So we can write, therefore the median lifetime of a lamp is equal to 3406.98 hours. Question number 6. 100 surnames were randomly picked up from a local telephone directory, and the frequency distribution of the number of letters in the English alphabets in the surnames was obtained as follows. So number of letters and number of surnames. Determine the median number of letters in the surnames. Find the mean number of letters in the surnames. Also find the model size of the surnames. So first we can do mod. Here maximum frequency is coming 40. So we can take the model class, that is 710. This is the model class. Now L is 7 and F1, F0, F2. So when we are putting there in the formula, mod is equal to L is 7 plus 40 minus 30 by 2F1. That means 80 minus 30 minus 16 into 3. It is equal to 7 plus 10 by 80 minus, it will come 34 into 3. It is equal to 7 plus 30 by 34. We are getting 0.88. It is equal to 7.88. That is mod. Then median. For median, cumulative frequency 6, 36, 76. Here cumulative frequency, the last one, and the total frequency is same. Then n is equal to 100, n by 2 is equal to 50. So the median class is coming 50 cumulative. Look at the cumulative frequency table. Above 50, that is 76. So the same class 7 to 10, that is the median class. Then there in the formula L plus n by 2 minus CF by F into H. 7 plus 50 minus 36 by 40 into 3. We are getting here median is equal to 8.05. Here we have to calculate the mean also. Small values data in the small numbers, so we can do that mean in direct method. HI midpoint 2.5, 5.5, 8.5, etc. Then HI FI direct method 2.5 into HI FI. Just multiply and we can write that as 2.5 into 6, it will come 15. Then 5.5 into 30, 165. That is sigma Fi HI 832. So we know that direct method mean is equal to sigma Fi HI by sigma Fi. 832 by 100, 8.32. So we got mod as 7.88, median as 8.05, and mean as 8.32. Mean number of letters in the surname 8.32. Model number of letters in the surname, that is 7.88. Median, that is 8.05. Question number 7. The distribution below gives the weights of 30 students of a class. Find the median weight of the students. So weight in kilogram, that we can take as the class interval 40 to 45, 45 to 50. It's continuous class interval. Then number of students, that is frequency. Then cumulative frequency 2, 5. Here total frequency 30, and therefore n is equal to 30, n by 2 15. Median class is coming after 15, that is 19. So this is the median class 55 to 60. Frequency is 6, cumulative frequency is 13. So we can put the values. L lower limit, that is 55 plus n by 2 is 15 minus 13 by 6 into 5. It is equal to 55 plus 15 minus 13, 2 into 5, 10. 10 by 6, it is equal to 55 plus 1.67. It is equal to 56.67. That means the median weight of the students. So median weight is equal to 56.67 kilogram.